Okay, good morning, everyone. Hopefully today's lecture is not too long. So for my Monday, Wednesday, Tuesday, Thursday classes that I've been teaching discrete since the beginning of the semester, not the new class, I've opened up all of the homeworks uh, back up. So all homeworks are now open until December 13th, I think. So if you've missed any homeworks, you have a chance to make those up. Also, most of you should see your grades posted for exam 2 unless they weren't sent to my Blackboard account. Most of you did this though. Um, as far as earning extra credit towards exam 2, I have yet to come up with a an idea that would be fair to everyone. I'm thinking about just having exam corrections, but I'm not sure yet. I'm going to decide by the end of the day. I'm going to talk with some other instructors about possible ideas for this. So just be wary to check Blackboard later tonight or early tomorrow morning. And today is December 7th, by the way. So either by the 8th, there'll be something up on Blackboard as far as earning points back for exam 2. Okay, so if you haven't seen already, there's an outline of the final project on Blackboard. For my Tuesday, Thursday, 8:30 class, I'm going to send out a specific set of instructions for you guys. So if you're not in that class, don't worry about it. If you are, you'll get more information tomorrow. So hopefully all of you have found your groups and have put together a general structure inside of Spider, a directory structure that follows the rules I posted on Blackboard and that I also mentioned in class. So you should have your main project directory. And I forget what I called this, maybe math 2305 final project. And then maybe fall 2020. So this should be the name of your main directory. Okay, and this is your project folder inside of Spider. And then inside of here, we're going to have several scripts and folders. So there'll be one folder called test graphs. And this is going to store all of your adjacency lists or your edge lists that you're going to test your algorithms on. Then there'll be a test.py script. There'll be a main.py script. There'll be an algorithm script. And then there'll be a functions script. And then a possible other script that we'll talk about today called drawings.py. Or drawing.py, I forget what I called mine. Drawing.py. So, okay. So again, just to describe what these scripts do, test is where you're going to test out all your basic functions that you're going to write, that you're going to put inside of here. So inside of functions are what I'm going to call your helper functions. And these functions are going to break down the pieces of Prim's algorithm into various smaller parts, right? Inside of algorithms, there'll be a function called prims that will call on functions inside of this script and implement prims. And I'm going to give you an example of what that looks like here in a minute. And then in main, you're going to have a main function that calls prims. So it's going to import prims from algorithm.py. Okay, and then inside of here, you're going to have your test graphs. And these graphs are going to be graphs that you're going to verify that your function is working, right? So your group is going to have 1 to 5 members in it. And you should break these tasks into pieces. So for example, there's a bonus part of the exam, and that is to use GitHub. Okay. So in order for you to get the bonus, I think it's 15 points, each member of your group is going to make a GitHub account and make a repository with this structure. So the way that I would do this is I would have the person that's most familiar with programming go and learn how to use GitHub, and then that person should help the other members of the group learn how to use GitHub, okay? And I'll put some links on Blackboard that will be helpful in learning how to use GitHub. Okay, this is a version control system that is widely used in industry, and every person that majors in computer science and data science needs to know what GitHub is by the time they graduate. And I find that a lot of CS students go their entire degree without ever knowing what that is. It's seriously one of the most important things that you can learn. So even though it's bonus, I really think that you should try to work with your members using GitHub. Okay. Now, what should this look like at the very end, right? Like my previous YouTube videos, I've shown you how to write most of your helper functions. I haven't done anything here, and I haven't done anything here. So what you might be kind of confused on how this should look. So let me go ahead and pull up my screen. Okay, how's that? Okay, so, all right, so I'm not gonna show you what's inside my functions script because I want you to finish that without me giving you every answer. So let me just close that out so you don't see it. All right, so, what is the function called? Prim's initialize. Okay, so from functions, I'm gonna want to import Prim's min edge, and I want to import initialize Prims. Okay. So I'm inside my algorithm script, and this is where I'm going to put Prim's algorithm. So what I'm going to do is I'm going to say Prim's algorithm is going to take in a graph G and a starting vertex. Okay. So let's see. We can say our tree is going to be initialize Prims, which is a function that we wrote last time. Okay. And then also, we have another function we wrote called is spanning. Okay. And then we can say while, say something like while is spanning, which is a function that we imported, GT. So while this is false, we want to update our tree. Okay, what's going on here? I think that will go away. So we want to say E is equal to min Prim's edge, which I did not write this function all the way out for you last time. It's up to you to figure out how to do that. min prim's edge. So that's grabbing the minimum cost edge, and this is a custom function that you write using the helper functions and functions. And then we want to update t. So t dot add edge, and I think the syntax is going to be E0, E1. Okay, so return T. So I don't think I need network X here because that's already taken care of. All right, so so long as your min prim's edge is working, this should be fine. This is exactly Prim's algorithm. So let me go to test now. Okay. So let's see what happens here. So I can say from algorithms now, import Prims. And that's the name of it, right? Prim's algorithm. Yeah. Okay. All right, so now we have this business here. Okay, so let's see what happens. Let's see, T is equal to Prim's algorithm. And there's G, and let's just pick a random starting vertex, maybe. I don't know, start at 0. Okay. Let's just see if we get any errors here. So, okay, let me take this off screen real fast. I don't want to show you that min prim's edge because that's the one thing. Oh, min cost edge, that's what I called it. Okay, so min cost edge. Okay, so now I'm going to save that. So this is the name of the function that I wrote to find the minimum cost edge that you can add. So I go back to test. Let me try to run this again. Initialize prims. What did I name it? Oh, prims initialize is what I called it in previous lectures. So let me just change that. So second here. There it goes. And then I need to change this here as well. There it goes. Save that. Still don't know. Oh, min cost edge. Let me change here. Okay. All right, so we go to main. Oh, no, not main, test. Sorry. So let's see what happens now. Okay, so what is T here? So V of T, T. So one way that you can verify this, and I'm gonna post a script to do this. So I made this drawing.py script. This is kind of a custom made thing for my students that I made. And it has show weighted graph and draw subtree. So let me just show you how you can use this. Actually, you should probably just, instead of me posting this on Blackboard, you should probably just pause the video when this is recorded and type in all of this and see if you can understand what it's doing. So that'll help you get a sense of what exactly I'm doing. So this is the script that I made. and I'm going to go into test, and I'm going to say from drawing import star. And that's going to import all the functions inside of drawing. Notice where drawing is at in my directory here. And I have show weighted graph, draw subtree. Okay, so let me just say, let me just show you how this works. I'm going to say draw subtree G, T. And hopefully this works. I just kind of thought of it before class to put this in, so I might have to change it. All right, let's see my plots over here. Oh, there it is. So this looks like the minimum cost spanning tree. Okay, so it would be nice if we could show the user, as we're adding these min cost edges, we could show give the user an option to look at the iterations of prims. So if I go into algorithms and I'm going to say from functions import so the two functions I have in here are show weighted graph, copy that there, and then also draw subtree. Let's grab this guy here, come back over here, that there. So we can have a optional keyword argument that we can pass into prims. And I'm going to call it show graph. And I'm going to set that by default equal to false. Okay. So then what we can say, so if show graph equals to true, show weighted graph is going to show the graph. So I can say show weighted graph G. So that's going to draw the graph initially. And then I'm going to put in another statement here. So if show graph equals true, I'm going to draw that subtree one time. Draw subtree G comma T. So what this is going to, all I'm doing is I'm giving if statements to just draw the graph at each iteration. Okay, so let's do here. So then if show graph is equal to true, then I'm going to draw the subtree again. So I'm just going to copy that and paste it. Okay, and that's just going to, you'll see how this works. So I'm going to save that now and go to test. And then here, instead of, I'm going to say that show graph is equal to true. So I'm not boolean there. So I'm just showing that, I'm just declaring that this keyword is now going to be true when we run this script. And let's see what it does. What is the name of? Oh, I'm not importing it from functions. I'm importing it from drawing. Okay, so I'm going to save that. Go to my test. Oh, and it's not inside draw subtree now, it's inside of Prim's algorithm. Show graph equals to true. Okay, so let's see what happens when we run this. Okay, so this is what it does. So here's our weighted graph. there's our initial tree. And then that's the min edge that we add. Next min edge, next min edge, next min edge, next min edge. And then we're done. So it gives a nice visualization of what's happening. And you can verify that your algorithm is working by, okay, if you start there, what's the min cost edge that you can add? It's that one, provided that you wrote the correct function. Okay. So this will for sure find the min cost edge. The min cost spanning tree. So I'd also like to know what the cost is, right? Like if you calculate this by hand, you're going to get some cost, and you want to verify that your algorithm is computing the same cost. So if I go back into algorithms and I say something like show cost, another keyword argument, show cost equals to false. Okay. Now, after you finish this while loop, this is, the original script we had did what we wanted, but now we're kind of making it more user-friendly right now, or more interactive, I should say. So if, if show cost equals true, we want to calculate the cost of the tree. Which basically means we want to sum all the cost of the edges in the tree. So we want to say something like, we want to also import cost and e from our function script, right? And we wrote these functions last time. So we can say c is equal to 0. Or no, we can say c is equal to the sum, if we use list comprehension, of the cost in the graph G of edge E for E and E of T. So in the edge set. So we're just going to sum all the costs, and then we want to show that to the user. So we can say something like print an F string cost of this spanning tree is, and just throw in C inside curly braces. All right, so if I save that now, and I go to test, and I say something like show cost equals to true. Okay, so now if we run this script, let's see what happens. Oh. Some error here. If I go back to algorithms, oh, it's not a Boolean check there. It's just defining show cost to be false. So now it should work. And let me just get rid of all these graphs over here. All right, so we're going to show it, and we're also going to show the cost. There's the cost then. I'd have to go in and see exactly what this new looks like NumPy or some NumPy or something has been changed, but probably inside my drawings function. But in any case, you see that it printed out the cost, and then there's the spanning tree, and then you can check the iterations of the algorithm. Okay. So so now that we know that this is working here, we can go to our main and kind of clean everything up. So this is how we initialized our graph, right? So what we can do is I'm just going to basically copy all that, go to main, okay, and then say something like, I don't know, write a function like def test prims. Or I kind of want to leave it up to y'all to do this part. So this is kind of up in the air as to how you're going to do this. I've seen several different ways. So inside of the main script, you just need a way for the user to input a graph that they want to run prims on, and then ask them if they want to show it, ask them if they want to show the cost, and then have inside of main a way to run prims on the graph that they want to test on. So in test graphs, you're going to try to put at least like 3 or 4 graphs in here to test on, right? I gave you this one graph called G1, which is this one, but you can make another one, I suppose. For example, let me just say, let me just make one up. So. And all of you can just make up your own graphs. So and I'm just going to say 0, 1, 2, 3, 4, 5, 6, 7. And then we can put weights on this. And I'm just making up these weights as I go. So like 1, 1, 2, 3, 1, 4, 6, 2, 1, 2, 3, and 4. I literally just made that up. So what does the edge list look like for this graph? So 0 to 1 with weight 4, 0 to 2 with weight 2, 0 to 3 with weight 3, 1 to 6 with weight 2, 2 to 4 with weight 1, 3 to 4 with weight 1, 3 to 5 with weight 1, 4 to 5 with weight 2, 4 to 6 with weight 6, 4 to 7 with weight 3, and then 5 to 7 with weight 1, and 6 to 7 with weight 4. I think that's all of them. Okay, now I'm just going to manually run Prim's algorithm now, so it doesn't matter where we start. So maybe I'll start at node 3. All right, so then there, and there, looks like there and then there. Okay, so what is the cost of this edge? So the cost of this tree, so it's going to be 4 plus 2 plus 2 plus 1 plus 1 plus 1 plus 1 . All right, so what is that number? 4, 6, 8, 9, 10, 11, 12. All right, so if I counted correctly, that should be a min cost. That should be the minimum cost of the spanning tree, connected spanning tree on this graph. So, okay, let me put this into my program and check to see it work. Check to see if it works. Okay, so I moved everything here. So let me say G2 is this graph. It's .txt. So 0 to 1 with weight 4, 0 to 2 with weight 2, 0 to 3 with weight 3, 1 to 6 with weight 2. Make sure there's white space here. 2 to 4 with weight 1, 3 to 4 with weight 1, 3 to 5 with weight 1, 4 to 5 with weight 2, 4 to 6 with weight 6, 4 to 7 with weight 3, 5 to 7 with weight 1, and then 6 to 7 with weight 4. So I'm going to save that, and that's called g2.txt. If I go over here and I just replace this, g2, and let's see if the iterations match up what we did. We started at node 3. Let's just see what happens. Okay, so that's our first graph. So we started there. And there it goes. And we see that the cost was 12. And that verifies that it is indeed working. You can't see the edges colored, but there are, so we can just, can't see it, but looks like these, there's an edge there, and there's an edge there. Okay, so it's up to you to kind of use main to get user input and see what, like maybe give them options of what graphs they can test on. Like you can test on G1, G2, blah, blah, blah. Get user input, and you can do that using input. But really, besides getting it working, the most important thing is to have everything well documented. Like, what are your functions? How do you document your functions? How do you clean things up? And in the PDF that I posted on Blackboard, there's a link to realpython.com and a really clear explanation of how to document your functions. Okay, so real Python. You just type that, maybe somewhere there's the link that I posted should be the one that you should use. Like this might be one of the paid ones. Yeah, this is not the one. It's free. I don't know. Just use the link that you see in the PDF. That should take you to to the correct way to document these things. But if not, you can also maybe if I go back, this is a Python package that me and my friend David Amos wrote together. And you can see that there is a certain way that you should write doc strings for your functions that you write. So you have your parameters, what your input is, what it returns, and then how you could use it. Okay. So I guess that will be it for today's lecture. There'll be no lecture on Wednesday. I'll just be trying to answer questions from the respective groups on Wednesday. So yeah, if I don't receive any, I'm still going to open up the Zoom link on Wednesday, but I'm not planning on lecturing. I'm just going to take questions from the groups. Okay. So I guess that'll be it. I hope everyone's staying safe. If you have groups, you more or less know how to format the project, and you just have to spend from now until the day of the final documenting your functions correctly, putting together the appropriate directory structure with the scripts and the folders, making a few more test graphs, running your algorithm on those test graphs to make sure that in each case you get the correct answer, and that's it. So,
Professor?
yes.
When is the due date for this assignment?
The day of the final, whenever that is. And you can look that up on the UHD website. So if you just type UHD final exam. And you should do this with all of your classes, by the way. Sometimes the dates will change from the beginning of the semester. It's rare, but it does happen. So you should double check when your finals are always on UHD, on the UHD website. So we are a Monday, Wednesday, 11:30 a.m. class. So our final is on the 14th. So this is due a week from today.
Thank you.
Which, by the way, I didn't share my screen, but if you just, all I did was search UHD final exam schedule, clicked on the first link, and then you'll see Monday, Wednesday, 11:30, 14th. My Tuesday, Thursday, 11:30. It's on the 15th. For my 8:30, it's on the 15th as well. All right. Okay, so let me get this video rendered, and then I'm going to post it to YouTube. And that should be it. It's been a rather strange and hectic semester, so I hope that everyone's doing well and staying safe. And hopefully we can finish it out and get 2020 behind us.
Thank you, Professor.
Y'all have a good day.